Mr. Si, Dr. Hu, and Dr. Tani-san. I'm glad I have this opportunity to make some presentation about what TECO has been doing. But honestly, the reason I think Dr. Hu invited me here is because actually my background is auto industry. I joined TECO last year. Before that, actually, I served at the Ford Motor Company for more than 26 years in Taiwan, China, Europe. So maybe because now I'm doing two sides things. Firstly, at the automaker side, actually my first job was purchasing, okay, buying the products from supplier. Now, I am a supplier to the auto industries, changing my role. So probably I might be able to give you some idea if from the component side, how to approach this new change. Because certainly the EV or AV revolutions is going to hit the whole industry like never before. We say this time the revolution is once in, probably not only lifetime, once in a 100 years revolution in the auto industry. So a lot of things going to change, right? But here I must admit, I'm no expert in the semiconductors, or I'm no expert in the manufacturers. So I'm here can only give you some idea, high-level idea what, from the TECO viewpoint, what we are doing, okay? But first thing, I must make a clarification. TECO does not produce semiconductor. So I'm not here because we are doing that. But we are customers of the important semiconductor like IGBT and SiC MOSFET, okay? All right. Before I dip into the detail, I'd like to give you a short video. So I think in the beginning of this session, Dr. Hu gave you some idea about the industry. So I'm not going to repeat it here, but I want to emphasize why the EV industry now about to take off. In auto industry, usually we have this kind of a non-consensus rule. If a new technology, if the tech rate hit 5%, it means usually the new technology going to take off 5%, right? So in terms of EV industries, in China, that's already like 27% in the first half of this year. The Europe hit around, I think, 17% in the first half of this year. Last year in the US, they're already over 5%. I think the first half close to 7 or above 7%. So the migration is beginning. Then the next inflection point, usually between 20 to 30% of the market share. The reason we say so, because if a new technology market share like that high, then becomes a hurdle for the manufacturers to decide which to invest, right? I think Tani-san would agree. It's impossible to invest in different kind of technology at the same time because it's huge investment. So at some point in time, the automaker need to decide which way to go. Okay, so usually 25%, 30%, then they need to decide, okay, the old technology maybe just maintain. They need to start to invest heavily in the new technology. So that's what you are seeing right now in China. If you go to Shanghai, almost every car is an EV, right? If even you go to like in New York, you look at the bus, all e-bus, right? So that's what's happening right now. But does that mean everything will go smoothly from now on? Because the grid, power grid is not ready. The charging infrastructure not ready. People still worry about the driving range, right? Also, safety issue was still from time to time. You can show some of the video on YouTube. Some of the EV just burn out, right? And it burned very, very quickly because the lithium nature. It burned. You just cannot stop it. Once it starts to burn, it burns to death. So that's some of the risk and also kind of a barrier for the EV go next way. Then the next one is we don't call EV anyway because we call it smart vehicle. An EV without a brand means nothing. It's just a vehicle. If you go to the EV, you need to change all your electronic architecture, we so-called EEA. You need to change the foundation of the vehicle, right? So it's not just changing the powertrain. You're changing everything. You're changing the brand. You're changing your neural system, which is the EEA. Okay, so that's the big picture about the EV. And also why now some of the countries, the EV industry going very fast, because a lot of big countries and also region put out very attractive incentive, like the US. Starting from 3 years ago, the infrastructure bill, last year's IRA bill, no matter charging, no matter EV, they provide very interesting, attractive incentive. Not only to the customer, but also to the industry, just like a chip build for the semiconductor in the US. Similarly, EU also doing that one. The reason for that, because if they don't do that, a lot of industry will be attracted to the US, and they are going to lose out. And guess what happened right now? If you read the news, a lot of Chinese EV makers now going into Europe. And if you read the news carefully, last month, the highest selling EV brand of model is not Tesla. It's a Chinese brand. If you check that out, right? So a lot of things happening right now, moving very quickly. So Europe also very worried about their future. So they are going to invest or provide attractive incentive, no matter on the consumer side or the industry side. China already doing that one for years, we know that. Japan is gradually start to do something, right? So that's the trend to drive the growth. And usually $1 of the government policy would attract $4 to $6 of the private investor. That's how going to be in the future from now on. So we are now on an acceleration path for the EV and the smart vehicles. Here, I'm just give you one map about the industry in Taiwan. Certainly, I miss a lot of things here because we just talked about the smart cabinet. Here, we didn't touch that one. Basically, powertrain, charging, and battery system, vehicle electronics, right? So those are the major things be changed by the EV, but not limited to those things. And certainly, there are many Taiwanese companies are investing in these areas. But for TECO here today, I'm going to talk about two things. One is the e-powertrain, the other one is charging, because that's what we are doing right now. Another thing I'm going to refocus, because so many, the range of the EV is so wide. So here, I'm going to talk about something you may not be that familiar, commercial vehicles. If you believe or not, actually, the best way to implement the EV or smart vehicles is starting from the fleet. That usually associated with the commercial vehicles, no matter light commercial or bus, or for example, the mining, right? You have a very big dumpers running around in the mining fields. Those are fleet. And if you want to change, you change all of them, and you provide the infrastructure to support. So usually commercial vehicles be overlooked, but usually they are the one going to do the pioneering work. For example, the AV, right? If you want to say you want to send the goods to the 7-Eleven during the night, that's commercial vehicles, not passenger vehicle. So most likely, the one to adopt some of the advanced technology are commercial vehicles. That's why I want to introduce commercial vehicles. And you can tell that from the number here, the CAGRs for the commercial vehicle, the e-commercial vehicles going to grow over 10% in every category over the next several years. And we believe even after 2027, the acceleration will speed up very, very quickly, all right? Here, I'm just give you some example of what TECO provided. Our product portfolio starting from actually 75 or 50 kilowatt all the way to 250. Now we are about to launch the 350 kilowatt direct drive powertrain with SiC. Actually, 250 kilowatt already with SiC inverters, right? So those are mostly for the commercial vehicle. But when we define the commercial vehicle, it's not narrowly defined as the vehicle running on the public road, including, for example, the AGV at the port, okay? Several ports, including Singapore and also some of the China port, they already use AV-AGV, right? And we are working with our partner providing those powertrain to those AGV. The other one is marine boat, right? And for example, the Northern Europe, Denmark, Norway, Sweden, they are now leading in the e-boat. And guess what they are using? Of course, motor, right? Very similar to the heavy truck powertrain, okay? And there are other things like the mining dumpers I just mentioned. So if we define the commercial vehicle wider, then you have a lot of flexibility to use. For example, Caterpillar, they change their diggers or those equipment vehicles to the e-powertrain already. John Deere changed their tractor, those for the farming, to e-powertrain and AV as well. So a lot of things moving very, very quickly. We can define all of them as a commercial vehicle because they use commercially. Okay, and their powertrain all very much like the commercial, like a e-bus or a heavy truck. So those are the one why TECO choose say we focus on the commercial vehicles at a powertrain. Okay. With the powertrain, naturally come with the charging, and charging has become such an issue, right? Because we are not just talking about the AC slow charging or DC slow charging. if you look at what IRA bill in the U.S. doing, they are promoting the high voltage fast charging along the highway, right? That's the important thing. Only you can implement all those things, you can encourage people to buy the e-vehicles. Otherwise, they always worry about where to charge. My former boss, the Ford CEO, Jim Farley, last week, he drove a F-150 Lightning, which is an e-pickup, from San Francisco down to LA, then to Las Vegas. And the thing he found out, and he also complained, although he, the one developed the e-car, is the charging. He found out it's not easy to find the charging. And even if they found it, probably the slow charging, but he was in a hurry. He couldn't wait like 2 hours for the charging. They need to be like 15 minutes, right? But he couldn't find sufficient fast charging station in the US. Similar situation still happen in Europe or even in China. China now, if you believe the statistic, they have 6 million, more than 6 million public charging ports. But guess what? A lot of them actually were built 5-6 years ago. And many of them probably already not in work anymore. So even statistically, they talk about 6 million. Who knows how many really work and how many are fast charging. So charging becomes such an issue. That's why TECO is getting involved in the charging from the US. And with our Westinghouse brand. If you don't know that, in 1995, TECO acquired Westinghouse Motor. So Westinghouse Motor is belonging to TECO. And we work with them very closely. And some of their technology, then TECO, absorb and then spread out. And they're still serving as a pioneering organization within the big TECO group, doing a lot of advanced things in the industry. Here, going back to the manufacturing, because today's topic is smart manufacturing. Here, I only talk about the high level because I'm not expert. I'm not going to pretend I'm an expert. But basically, when we talk about manufacturing, there are two flows. One is material flows. The other one is information flows, right? All the so-called smart manufacturing is how to integrate two flows into one. That's why we talk about the Industry 4.0, digital twin, all kinds of things, because the best or the most efficient material flow must be supported by a very high efficient information flow. And that they go back and forth at every point of contact. The other thing is that with all those information flow back and forth between the real material flow and your information system, then come to a lot of judgment time or judgment point. For example, it's quality good, go here. Quality no good, go there, right? Or you need to adjust your CNC speed because feedback tell you, no, something wrong in your statistical number. You need to change. You need to have the feedback system. That's how the AI system coming into those two flows, right? In order to make the adjustment or adoption as quickly as possible, you got to have a very quick edge computing functionality to tell, for example, your CNC machine, you need to do some change right now, or you stop. That's how those material flow and information flow interact, because based on the sensing, based on the data collection, based on the analysis result. All right, so that's a high idea about how we define the smart manufacturing. It's not just use a lot of robots, right? Or a lot of sensors. It's too easy. You maybe can do that section by section, but if you want to maximize the efficiency, the whole thing, you need to treat that a one material flow with cohesive one information flow. So from the beginning to the end. Okay, that's the idea, okay? The other thing is, to make the manufacturing highest efficiency, you start from design. We call design for manufacturing. I think most of you know that, but it's very difficult to achieve that one. I think Tani-san knows that, right? A lot of time, it becomes a compromise. We design something beautifully, but too complex. The manufacturing guy just don't know how to produce. Then we need to come back to the drawing board and say, oh, I need to tweak that one, I need to change that one, I need to change the material, I need to change the spec, boom, 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 boom. And then you come out with a compromised product. So that becomes another hurdle about the smart manufacturing. How in the very beginning, when we start to design the new product, we have our manufacturing guy come in, work together. So when we design, we don't come back forth, eventually screw up ourselves. And the other thing is, just like the semiconductor industry, you are finding the best way to, best manufacturing process or equipment like SMOS, right? Even a traditional manufacturing company like us, we also need to find out the best way to change. Otherwise, the funny thing will happen because our designer can only design something like our manufacturing can do. That becomes a downward spiral because your capability and your competitiveness just gradually winding down, which is really no good. So we very much emphasize this one. However, I must admit, we still have a long way to go. Right? To achieve that way, we still need to train our people, manufacturing engineer, to understand the limitation about the equipment, also the limitation about the design, for example, material specs, right? Just give you some idea, when we talk about the motors, maybe not many of you, have the opportunity to take a look at how a motor being put together. Here also inverter as well, just as a simple demonstrations. In the video, you probably already saw that that's the rotor. And then we have a stator. And then we have a shaft. So how to put together something just like the rotor assembly. And then the stators depends on your design. You have the traditional way, the round wiring, or the new one, we call the hairpin design, the rectangular design, to maximize the energy densities. But the manufacturing process for those two wiring process are totally different. So to do the hairpin design, the manufacturing process now we have cannot do that. We need to change the whole equipment totally. Right, so that's a new generation of the motor design. And also the motor design itself, they have a lot of change. Why Tesla be recognized as the best motor designer? Motor is motor, right? No, because there are a lot of ways to maximize the magnet power inside. So you can see they have a different kind of shape around the motors, right? And they are actually pioneering in the motor design. But even now, talking about Shitu, right? The rare earth materials. I think 3 months or 4 months ago, Elon Musk talking about they are going to develop some no rare earth material motor. That's another things that we are watching very, very carefully because that's going to be another breakthrough if they can really succeed. Not only them, several other companies are competing in this area as well. So it's going to be a very interesting race for the motors, okay? I'm going to skip this one. So when we talk about smart manufacturing, basically we also talk about green manufacturing. It goes hand in hand, especially nowadays, right? We talk about carbon footprint, how to reduce the carbon. TECO already made a commitment publicly. We're going to reduce the carbon footprint about the 2020 carbon footprint by 50% before 2030. So we are on the way. Starting from this year, actually, we also assign the carbon budget to each of our functions, just like some of the company do in Taiwan, right? Try to reduce the carbon footprint, right? So I'm not going to dive deeply into the detail. So I saw them, no, I got a few minutes to go. So just come to the conclusion very quickly. A lot of new change, technology breakthrough are driving the manufacturing process change, right? Just like I just mentioned about helping design, which is totally different from the traditional one. And for a high density or high power, you probably cannot use air cooling. You may need to use, even sometimes water cooling is not enough. It becomes using the oil cooling. So when you have the helping and you have the oil cooling, the whole inner design of the motor is totally different. And in some of the even higher density design, their inner core using the oil cooling, outer core use water cooling to achieve very, very high efficiency and also reduce the space. Okay, because in vehicles, space is also a very important factor to consider. So with all those change, we got to change our manufacturing process. Almost every time we got a new technology breakthrough. The other thing is that, as I mentioned, material flow, information flow, how we integrate all those things all together, and together with the design for manufacturing concept to make the whole process smart and green from the very, very beginning. Okay, so that's my presentation today. I know it's too rough, too high level, but if you have any question, I work on your question. Thank you.
Thank you very much.